So there's already a video on the front side of this practice test. Let's go to the back side of this practice test. The instructions say solve the following by applying any method you like, right? So you're not forced to factoring, splitting, and solving. You're not forced to pulling out a GCF. If you wanted to, you could do the quadratic formula on every single problem if you wanted to, all right? So if you want to forget about everything else and throw away all your tools except for the quadratic formula, you could do that if you want. Okay, so let's go through number 11. Would it be the best option to use a quadratic formula? No. Why not? Because it's so easy to factor, right? The a value is 1. Whenever the a value is 1, I always try this. Because it's so easy. It takes a couple of seconds to think, what times what is C that if I combine together is B? Now, if I can't find that combo, then yeah, I'll use a quadratic formula. But if I could find it, then it's really easy. 1 times 8 is 8, and if I combine it together, it's 9. So it's not 2 and 4, it's 1 and 8. So let's put that 1 and that 8. So it's factored, and it is equal to 0. So now let's solve it by splitting it. X plus 1 equals 0. X plus 8 equals 0. Solve both. You're going to get x equals negative 1 and x equals negative 8. So those are your two answers for number 11. Easy peasy, right? Number 12. Even if I wanted to use the quadratic formula, I'd have to set it equal to 0, right? So let's first do that. Let's get that 8x over to the other side, subtracting 8x. Let's rewrite it. We're going to have 9x squared minus 8x. Now it's equal to 0. So if I wanted to use the quadratic formula, I would have to identify my a value, my b value, and my c value, which happens to be not there. It's 0, right? So I could use a quadratic formula if I wanted to, but is that the best method on this one? No, there's a faster method, which is pulling out the GCF. That's right. So let's pull out that GCF, which happens to be x. What would be left over on the inside? 9x minus 8. And of course, it's equal to 0. So let's split it and solve. We have something times something equals 0. The first something could be 0, and the second something could also be 0. And you got to solve both. This one's already solved for you. That's an answer. The other one, after you add 8 to both sides, you'd have 9x equals 8. Then you'd have to divide by 9 on both sides, and you'd get the answer x equals 8 divided by 9. This was from our most recent quiz, I believe. So the questions are not going to be identical, right? They're going to be very similar. I might change a number, but yeah, similar, almost the identical process at least. Jumping to number 13. Once again, even if I wanted to use the quadratic formula, I would have to move everything to one side to get it equal to 0. So let's subtract 3. Subtract 3. We're going to have 12x squared plus 16x minus 3 equals 0. So if I wanted to use my quadratic formula, my a value is 12, my b value is 16, my c value is negative 3. On this one, I know that you could factor it using the multi-step process because the a is 12, and step 1 would be to multiply a times c. But if I were to try to do this method of a times c, that's 12 times negative 3, you get negative 36. And when I try to find my list of numbers of the multiples of negative 36 that combine together to give me the b value, which is 16, if I can't find that pair of numbers, I'd have to go back and use the quadratic formula, right? So maybe trying to factor it is not the best option. Maybe the quadratic formula is the best. But let's continue. Let's try it at the very least. What times what is negative 36? Negative 1 times 36. Negative 2 times 18. Negative 3 times 12, negative 4 times 9, negative 5 doesn't work, negative 6 times 6. Those are all the pair of numbers that combine, or that multiply together to give me negative 36. And which pair of numbers combines together to give us 16? Negative 2 and 18. If we combine that, that will give us a positive 16. So this is the pair of numbers that I want. Now, I could convert this trinomial to a polynomial so I could factor by grouping. Or I could use the shortcut, jump right into the factored form answer format with the ax as the beginning part of each of the binomials, right? So what would my ax be? 12x. And the pair of numbers from step 2 go right in here. So let's put that -2 and that +18. Now, the final step of the shortcut is to magically divide each of the binomials by whatever you can, the greatest value that you can. Now, if you can't divide it at all, just rewrite it. That'll be your answer. But right here on the first binomial, I could reduce both of them by 2. I could divide both by 2, and I will get 6x minus 1. And on the other one, I could reduce both of them by what? 6, right? Some people say 3, but the greatest would be 6. And that'll be a 2x plus 3. So that's factored. However, this is an equation equal to 0. So I still need to set it equal to 0. Man, this is still pretty long, even with the shortcut. Maybe the quadratic formula would be best. But anyway, let's split them. 6x minus 1 equals 0, and 2x plus 3 equals 0. So you'd have to add 1, add 1. You'd end up with 6x equals 1, which means that your final answer will be x equals 1/6. When you divide by 6, divided by 6, x equals 1 divided by 6. And the other one, subtract 3, you'll have 2x equals -3, which means x equals -3 divided by 2. So those are your two answers for number 13. Would the quadratic formula have been faster? Maybe. I don't know. Especially you could use calculators, so it's not that bad. Number 14. By the way, guys, it says up here, maybe I can't even speak. Maybe I will replace some of these equations with the quadratic formula worksheet 4.6. All right? Sorry about that bad writing right there. But anyways, let's go to the worksheet 4.6. Pull it out. So here's the worksheet 4.6 WSP, and I only gave you the odd ones, right? So from this worksheet itself, I am going to select some of these and replace, I mean, I'm not going to leave these exact questions. I'm probably going to get some of these, and this is a great worksheet. I love this worksheet because even though it says use a quadratic formula, a lot of them, there's faster options than using the quadratic formula. Like number 1 is pulling out the GCF. Like number 3 right there would be the quadratic formula, but you'd have to subtract 3 to both sides. So I'm going to be picking equations from here, all right? I already made a video on this worksheet, 4.6. I recommend going back and watching that video because those questions will be selected to be on the test itself. So keep that in mind. Maybe since we didn't do one with the quadratic formula, maybe we should do one with the quadratic formula. How about, should we do number 7? Number 7, of course, the first thing you should try to do is to factor it so you could split it and solve it. But when you start thinking what times what is a C value 3, that if you combine together is -6, it doesn't work. It's not factorable. So because it's not factorable, you can't do that option. And that's where you must use the quadratic formula. The A value is 1, the B value is -6, the C value is 3. When you use the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac divided by 2a, I recommend that you replace your variables with parentheses. And then after that, you simply plug in your b value of -6 right into there, your a value of 1 right there, and your c value of 3 right there. You always begin with your discriminant value. -6 squared is positive 36. And then -4 times 1 is -4, times 3 is -12. So you do end up with a 24 inside your square root. So your discriminant is 24. Out in the front, you really do have a +6. So let me write that down. +6 plus or minus square root of 24, all divided by 2. And of course, the square root of 24 could be broken down to a perfect square number with multiplication. So you're not going to say 2 times 12. You're going to say 4 times 6. 4 is a perfect square number. So when you split it, you could actually do the square root of 4. You'll get 2. And the square root of 6 stays the square root of 6. So my answer is x equals 6 plus or minus 2 square root of 6 instead of the square root of 24, all divided by 2. And you could reduce this answer, everything by 2. So if you divide the 6 by 2, you'll get a 3. Divide the 2 by 2, you'll get a 1. Divide the 2 by 2, you'll get a 1. So your final answer is 3 plus or minus 1 square root of 6. But to be honest with you, that 1 is not necessary. You could just leave it square root of 6. So there's your answer, 3 plus or minus square root of 6. So I just wanted to show one where we did use the quadratic formula, because on the quiz itself, like I said, I'm going to be picking some of these from the worksheet. On the quiz itself, on the test itself, there will be some where you have to use the quadratic formula. So let's just do 14. 14 and 15 are the same. I'm probably going to delete one of those. You'd have to get rid of the 35. Yeah, 5x squared equals negative 35. And you'd have to divide by 5, divide by 5. You'll have x squared equals negative 7. You apply a square root, x equals, don't forget the plus or minus. This negative sign, it's going to come out as a I, variable I. So you're going to have I, and the square root of 7 cannot be broken down, so that'd be your answer, x equals plus or minus I square root of 7. The final part of your quiz, oh yeah, by the way, right here I'm telling you, I'm going to pick questions from that quadratic formula worksheet 4.6. So please practice by picking some, writing them in here, and checking it. Please watch the video that I posted on that worksheet. Anyway, there's going to be one of these. Anytime you have a negative on the inside, it's going to come out as an I. So you're going to have an I on the outside, square root of 32 on the inside. Square root of 32 could be broken down with multiplication to get a perfect square number. Let's not go with 4 and 8. Let's go with 16 times 2. So that way when you split the root, the bigger perfect square number saves you a lot of work. So the square root of 16 is 4. Square root of 2 stays. Let's not forget about the I. So you really have I times 4 times the square root of 2. Final answer will be 4I square root of 2. The number first, the I second, and the radical at the very end. Number 21, that's going to be on the test for sure. I to a certain power. Might not be the same power, probably a different one. But the bottom line is you need to know I is just I. I squared, everybody should know, is negative 1. I to the third is simply going to be I squared times I, which is really just negative 1 times I, which is really just a negative I. Then I to the fourth is really I squared times I squared, which is really a negative 1 times a negative 1, which means that I to the fourth is really a positive 1. Okay, so if we understand that I to the fourth is positive 1, then I to any power that's divisible by 4 is going to be equal to 1, right? So I to the 41, I could really rewrite this as I to the 40th times 1 more I. And I do know that this is divisible by 4, so that's really just 1 times I, so my final answer is just I. You get it? Okay, so obviously I'm not going to give that exact one on the test. I might give you, how about I to the 22nd? Let's do that one, just right here on the side. I to the 22nd. What could you rewrite I to the 22nd as? I to the 20th, which is divisible by 4, and then how many more I's do we need? I to the second. So what's your final answer if this is 1? It's going to be negative 1, the final answer. Why? Because this right here is 1. I squared is negative 1. 1 times negative 1 is negative 1. So just keep that in mind. It'll be a different power on number 21. Or on this question on the actual test. Now, I'll tell you this right now. I think we have too many questions on complex numbers right here at the end. So this is a subtraction problem. This is multiplying. We're going to have to multiply a binomial times a complex number times a complex number when we get rid of this complex number down here. So I'm probably going to skip over or delete that one because you're going to have to do this work on this problem anyway. Yeah, so I'm going to definitely shorten this piece. There's probably, instead of 1, 2, 3, 4, 5, 6, we're only going to have 3 or 4. All right. Anyway, let's continue because we don't know which ones I'm deleting. Distribute that. You'll have a minus 2. You have a plus 8i. Bring down the 11 minus 8i. And now it's just about combining like terms, right? Combine the i's with the i's and the numbers with the numbers. Of course, you want your real part first. So let's go 11 minus 2. What's 11 minus 2? 9. We have 9. And then how about minus 8i plus 8i? 0i. So that's it. Your answer is 9. If I do keep this problem, I'll probably make sure that these don't cancel out. That way you actually have an imaginary part to this answer. Number 23, it's most likely I'll delete it, but let's practice anyway. We have 4 times 2, which is 8. 4 times negative 5i, which is negative 20i. Then we have positive 3i times 2, that's a positive 6i. Positive 3i times negative 5i, that's a negative 15i squared. Now we should all remember that I squared is really a negative 1, right? So you really have negative 15 times negative 1, which is going to be a positive 15. So what do we really have here? Let's combine the middle term, negative 20i, with the positive 6i. That's going to be a negative 14i. Bring down the 8, and now let's combine the positive 8 with the positive 15, giving us a positive 23. Don't forget about the minus 14i. And that's the way you're supposed to write it. The real part first, the imaginary part second. Number 24. I'll be honest with you, I'm probably going to delete this one from the test. Why? Because if you're able to do this one, you're definitely going to be able to do this one. I'll explain it anyway right here. The I value, you need to get rid of it. You can't have an I in the denominator. Now, if you did have a complex number, a binomial, then you'd have to multiply by the conjugate, which would mean the same exact binomial, but with a plus instead of a minus. Okay? But we don't have a binomial. You just simply have one single negative 2i. And in order to get rid of the I, all you have to do is multiply by one more I. Because we know that I times I is I squared, which would be a negative 1, which would take that denominator to be a positive 2. So we could get rid of the I by simply multiplying both top and bottom by a regular I. The only thing is up on top I do have a binomial. So let's distribute I times 6, that's 6i. I times 5i, that's plus 5i squared. And we should all know that I squared is really a negative 1. So what we really have up on top is 6i plus 5 times negative 1, which is really a 6i minus 5. Now remember, you want your real part first, your imaginary part second. So let's switch them. Let's put the minus 5 over here and the positive 6i second. Now this is the top. How about the bottom? Well, on the bottom we have I times I, that's going to be I squared. So we have negative 2i squared. And we know that I squared is really a negative 1. So you really have negative 2 times negative 1, which is really a positive 2. This is the bottom. So we really have negative 5 plus 6i over 2. And we're going to split the denominator to each of them, and you'll have negative 5 over 2 plus 6 over 2 with an I. So negative 5 over 2 can't be reduced, but 6 divided by 2 is 3 with an I. So there's your answer for that one. And number 25, we need to multiply. To get rid of this I, we need to multiply it by the entire binomial, but the conjugate of it. So we're going to multiply by 1 minus 3i. When you multiply a binomial by its conjugate, the middle terms disappear and the i's disappear. So up on top, we also need to multiply by the same conjugate, 1 minus 3i. Whatever you do to the bottom, you must do to the top. So anyways, let's distribute. Up on top, you have, this is a binomial, so you have 2 times 1, that's 2. 2 times negative 3i, that's negative 6i. Negative 4i times 1, that's a negative 4i. Negative 4i times negative 3i is positive 12i squared. Now the I squared is really a negative 1, so I really have a 12 times negative 1, which is really going to be a negative 12. Now let's combine like terms. Let's start with the real numbers first, all right? Let's combine the real 2 out here in the front with the real minus 12. It's going to give us a real minus 10. Then combine the imaginary negative 6i with the imaginary negative 4i, you're going to have an imaginary negative 10i. So that's what you have on top. Let's see what we get on the bottom. We're going to distribute as well. 1 times 1 is 1. 1 times negative 3i is negative 3i. 3i times 1 is positive 3i. Positive 3i times negative 3i is negative 9i squared. And again, the I squared is a negative 1. So what we have here is 1 minus 3i plus 3i cancel out. Minus 9 times negative 1, that's going to be a positive 9. So what we really have in the denominator is 1 plus 9, which is 10. And the 10 goes right there at the bottom. So because this is all divisible by 10, it's best that we get this answer, split it into two parts, the real part first. So you're going to have negative 10 divided by 10. And then you're also going to have negative 10 with an I next to it divided by 10. So your final answer is negative 1 minus I. So I would definitely go back and go to that worksheet, this worksheet right here. Watch that video on this worksheet 4.6 WSP, because I will be selecting questions from that worksheet, from that video, to be right here on these spots. Or I might even replace these up here with those questions from the video. Good luck.